We've now gone over functions and some of the specialties that come with them when we're doing them in programming languages, and there's one last specialty that we have to address. Now, a function in math is generally one that returns a value, right? It does some sort of mapping, and there's an input and there is an output. So what we said previously was we may have functions like f of x equals 3x plus 4. And what this does is, right, whenever I just use it, like let's just say f of 3, all this does is it goes in and it replaces wherever it sees x with a 3, and then it computes some kind of number. So here it would be 13, right, because 3 times 3 is 9, plus 4 is 13. And so we expect some kind of value whenever we finish something like this. And same thing goes if we're doing other kinds of functions like transformations and maybe geometry or some kind of mapping with a set or vector math or anything like that. But we have to consider that there are some other things in the real world that we want to be able to do in programming languages as well that aren't covered by math functions but that we can do. And so an example of something like that that I have in mind would be something like driving a car. So you drive a car, right? And it's my best car, and it drives. As far as that action, there's not really some kind of return value to it because you just drive the car and, does the car give you an integer or a boolean or a character? It doesn't really make a whole lot of sense. Another example of this, I would say, would be making a sandwich. So if I wanted to write this as some kind of function in C++, remember that we do it like this kind of, and we write the code in here. And so you might do something like, okay, well, go get the bread. And then you put stuff on the bread. And then maybe you'll close the sandwich and then maybe eat it afterwards or something like that. And so there's kind of like a list of steps that you take, and they're all kind of independent actions, but you don't necessarily have a result when you come back with this. Maybe you would say a sandwich in this case, but let's say if you eat it, then you don't really get anything back. It's just kind of an action that you do, and it has a bunch of things that follow after each other where we do stuff, but there's no inherent value to what we do. Not in like a moral sense, but in just a what do we get back? Not really anything tangible. And so when we have a scenario like that, what we want to do is use something called void. So whereas we've been returning values previously, something like an integer or a boolean or a character, if we want to do an action that doesn't have a value to it, the way we do that is with a void function. And so a common example of this would be, something like make a sandwich. More applicable to C++ might be something like void and then print. So let's just say print a menu. And generally, all a void function does is it does some kind of action where it doesn't need to give you some sort of response. So printing a menu, for example, where it just couts, let's just say, these are your choices, and then prints out all the choices that you can possibly make. I'm going to abbreviate this so it's not going to be like completely readable English, but maybe say A, add, and then D for divide, and you just make like a whole list of this, right? And you have to print this all out. This is an action because you are doing something to the screen and then you don't really expect anything back because it doesn't make sense for this to, return an integer or a character, or it's kind of hard to tell, right? What kind of value does this have? And it's questionable. Maybe you'll write this to return a character or something, but if we're just printing the menu and not doing anything else, then I don't think we need to have a value to that. And so if you ever want to do a scenario like that, then all you have to do is write void in place of the data types that we've been doing so far. One thing to note about void functions is that because they don't return a value, if you ever want to leave a void function, you simply put return and then nothing after it. So whereas if we had an integer returning function like we had previously, then you would return something like 0 or 1, which you'll see is what we do in main, right? Because main returns an integer. It's marked as int main. So it returns an error code, or an exit code, I suppose, which could be an error code or a success code if you return 0. But if we're just returning from something that doesn't have a value, then we don't need to return a value. We can just put return. Now, if you don't put a return in a void function, the C++ compiler will put it there for you. It just assumes, okay, well, you're done with the code. I will return. And it doesn't need a value to it, so you don't need to return anything with it. Let's talk about one last feature that comes with functions in C++. So let's just say, for the sake of what I'm doing, that I wanted to be able to take the distance between 2 points. And what I'm going to do is I'm going to do 2 different ways to find distance. So there's the classical way, right, where you have 2 points. So let's just say this is point 0, and it has coordinates x0 and y0. And you have another point, P1, that has coordinates x1 and y1. Then the Euclidean distance, which is like the normal distance that you are probably used to taking from high school math, is just the direct distance if I was just to draw a straight line from this point P0 to that one. So it's in red here. And the Euclidean distance is just, it's the square root of x1 minus x0 quantity squared plus y1 minus y0 quantity squared. And this works, right, because we just basically take a right triangle and then we find the hypotenuse, right, is how this works. We draw a straight line. Now, one thing to consider about this is that the output, generally because it's a square root, it's probably going to be a decimal, usually, unless it's a perfect square. So this realistically would return a float, right? It makes a whole lot of sense for that to be a float. Now, there's another kind of distance that's very common for us to do in computer science, and it's called the Manhattan distance. And so this would actually just go straight left and right, and then straight up and down at a right angle, and that would be the distance. So if this was, let's just say the x distance, so I'll say dx, and this is dy, then it would be dx plus dy, right, is the distance that you would walk if you were to walk like straight left and right, and then straight up and down. And it's called the Manhattan distance. And if you can kind of imagine Manhattan, it's a big city. I think it has 2 T's. Big city, or a big part of the city in New York City. You kind of have all the streets are in rows, right? So they're like this, and you have blocks, so you might have like First Street, Second Street, and then A, B, C, kind of like that are all parallel to each other. So if you actually wanted to walk to a building, let's just say that's on 3rd and A Street, and you wanted to get to a building that is on 2nd and C Street in Manhattan, then what you would do is you would have to walk a block to the right, or a block to the east, and then a block northwards, right? So you would walk a total of 3 blocks here, 2 blocks to the right and 1 block upwards. And the reason they call that Manhattan distance is you can't just cut across the buildings in Manhattan, right? Each of those blocks have buildings in the middle, so you'd have to fly if you wanted to make a straight line. So sometimes when we do distance, it's not realistic to just draw a straight line like Euclidean distance, and sometimes we have to go the long way around and go, on a grid of some kind. And so what we can do to find that is we can do something like this dy. So this dy here is like how far we move up and down, and then the dx is how far we move left and right. And so the distance of dy, so here I'll just write it like this first, is dy plus dx. Dy would be how far these y's are apart, so this would be the y1 minus y0 part, and then it would be plus x1 minus x0, which would find the dx part, which is how far this is left and right. And something to notice about this is whenever you're walking blocks in Manhattan, you just kind of like walk one street at a time, right? You want to walk 1 block, either up and down or left and right. And so it would make sense, in my opinion, for this to be an integer value, right? You maybe want these coordinates to be in integers, and you want these coordinates to be in floats. And so we have 2 ideas here, maybe that we're finding distances, but one is an integer type and one is a float type. And so one feature that we can do in C++ is we can actually give things the same name and then figure out how they work depending on the types that they return, and on top of that, the parameters that they take. And they must have different parameters, otherwise we can't actually tell the difference. Otherwise, it's not doable. Let's make this a little bit more clear by actually trying to program this. I've gone ahead and coded this up now. I have three functions here. I have the two find distances that we talked about. So notice that I have one that returns a float and one that takes an integer. And so the float one we said is going to be the Euclidean distance, and the integer version is going to be that Manhattan distance we talked about. And the way it's going to be able to tell the difference between those is the fact that there is one that uses entirely floats. So you see I have floats here for all the coordinates, x0, x1, y0, and y1. And then I have another one that takes in integers for all the coordinates. And so it will be able to tell which one I want just based off of the kind of variables that I'm using. And I've created another variable here for the sake of demonstrating void functions, as well as for something else interesting we'll see here called Printpoint. That's simply going to print a point, and it takes the x coordinate and the y coordinate. I've implemented them down here. All the Printpoint does is prints two parentheses, a comma, and then the x and y coordinate, and it takes two floats, an x and a y. And then here I have two find distances. So here we have the Euclidean distance. I've written it as such, and then I've written the Manhattan distance. And I went ahead and put absolute values on this just to make sure that if you're going to the left, that doesn't cancel something out, like going up, and those don't cancel out, because going to the left would be technically negative in this scenario. Anyways, if we go back up here to main, I've declared a couple points here. So I've declared a point 0 with an x and a y that are floats, and a point 1 that are again floats for an x and a y, and then a point 2 and a point 3 with x and y coordinates that are integers. And then after that, I basically just print them and take the distance. And so what we're saying here is that when we take this one, it's going to go ahead and run the float version of it, and when we do the integer one, so notice that all these points are integers, that this one is going to call the integer version of it. And just to see that that's the case, let's go ahead and put a C out here. So we'll say finding Euclidean, and then we'll put an end line, and we will do finding Manhattan here. And it's going to make my print look a little poor, I guess, but we should see that it calls each one. And now something strange that you might notice is that I wrote one print point function, and I did that on purpose. I could do a scenario where I write one that takes integers and one that takes floats. Something interesting about when we do function overloading like this, where we use the same name, is that if you only have one function, it will first try to cast, or I guess coerce in this case, all of the types to that data type. So here I use print point on point 2 and point 3, which are integer data types. Remember, I already set up here. Point 2, both the x and the y are integers, and point 3, same. And so I'm using it on point 2 and point 3, even though it takes floats. And if it doesn't find something that matches exactly, whereas these ones do because they take entirely integers and entirely floats, it will try to coerce them. And so because an integer can be converted to a float, and vice versa kind of works too in this case, then it will go ahead and do it. So you'll notice that these are going to get printed out correctly, even though they're integers being supplied to a function that takes floats. And so if we run this, we should see that everything works. And there we go, it prints out. Again, it does look a little poor. I said in advance that the formatting is going to get messed up because of the way I'm printing, but you'll see that the finding Euclidean part, which was in the Euclidean function only, it was in this version where we took the Euclidean distance, only gets calculated when I call the function with floats, and the finding Manhattan text is only printed out when I called the function with integers. Again, if we look at main here, right, I have two functions both called find distance. They have the exact same name, but they go to different functions depending on which one I'm using. And so they seem to work. I'll probably comment these out for the skeleton code just so that it looks a little bit nicer, but you'll see also that the printing of points worked as well, right? It puts the comma and the parentheses around it, and it works on both this one with the floats and this one with an integer, even though I only gave it floats for the parameters here. And so it will figure out what type makes sense by looking through all the functions and trying to match which one works the best. One last thing that I want to leave with is why even use functions. So I'm writing all this code, but I could just write this all in main too, right? There's nothing stopping me from doing that. And you would be right. I could write all of my code in main and there would be no problem with that. But consider, let's just say in this program that I use Printpoint 4 times. I call this function 4 times. And so if I didn't write a function, I would have had to physically rewrite the code that's contained in Printpoint 4 times by hand every single time I want it. And that's annoying because A, I have to type a lot, and B, it becomes way harder to read my code. And so what's common is to write these functions when you want to be able to reuse code. If you know you're going to be doing the same action over and over again, then it's a very good idea to write a function that does it for you so that you don't have to keep rewriting that code. And so these will all just jump down here and reuse the same one line of code instead of continuously having to write it every single time that it is written. So I think that about wraps it up for functions. In the next video, we'll take a look at arrays.